In this video we will see about what is meant by k-means clustering, and after that we will solve one example with the help of k-means clustering. Basically clustering is nothing but the grouping of the objects into classes of similar objects. So k means what? K is the number which represents the total clusters which are available. Suppose value of k is 2, that means total 2 clusters are available. That means we are going to divide the objects into 2 clusters. K means is one of the simplest unsupervised learning method among all partitioning based clustering method. It classifies a given set of n data object in k cluster, where k is the number of desired cluster, and it is required in advance. And a centroid is defined for each cluster. That means all data objects are placed into a cluster having centroid nearest to the data object, and after processing all data object, k-means or centroid are recalculated and the entire process is repeated. All data objects are bounced to the cluster based on the new centroid. For example, you want to find a 2 cluster. Okay, for finding a 2 cluster you have to go through this 5 step. First is what? You have to assume k value. That means suppose first centroid of object is, suppose I am assuming 2, and second centroid is 4. That is your assumption. This is the first step, that you have to assume the k value. In second step you have to initialize the 2 centroid randomly. I am initializing 2 centroid because I am assuming the value of k is 2. In third step, discover the point which are nearer to centroid by using Euclidean distance. That means you have to find the object which are nearer to that centroid and make a cluster. Okay. In fourth step, select the group and find the mean value and update the centroid. This is your fourth step. And in fifth step, repeat the previous all steps till you get the same centroid. So these are the steps for solving the k-means algorithm, and this is the formula for Euclidean distance. That is, here is your first point p1 which contain x1 y1 point, and here is your second point, that is p2, which contain x2 y2 distance. So Euclidean distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula for finding Euclidean distance. Now we have given these objects 2, 3, 4, 10, 11, 12, 20, 25, 30, and we have to solve this. We have to make 2 clusters of a given object. Suppose, and here given that value of k is 2, that means you have to make 2 clusters. So k is equals to 2, that is given. So suppose value of first centroid I am assuming as a 4. So this is my first step, and value of second centroid that I am assuming as a 12. Okay, now see which objects comes in first cluster. So what is the first object? 2. So 4 minus 2 is 2. So here is what? 4 minus 2 is 2, and 12 minus 2 is 10. So this 2 is means which is nearer to this M1 cluster. So 2 comes in first cluster. Second object is 3. 4 minus 3 is 1, and 12 minus 3 is 9. So 3 is nearer to M1 cluster. So 3 comes in M1 cluster. Likewise 4, which comes in M1 cluster. Then 10. So 10 is what? 4 minus 10 is 6, and 12 minus 10 is 2. So this is minimum distance. So the point 10 comes in M2 cluster. After that 11. 12 minus 11 is 1. So this 11 comes under M2 cluster. So here is 12, which also comes in M2 cluster. Likewise 20, which is nearer to 12, so it comes in M2 cluster. Likewise 25 and 30, all this comes in M2 cluster. Now this is how we have created the cluster based on the assumption. Now you have to find the average of m1. What is average of m1? 2, 3, 4, that is 3. And what is average of this m2? 10 plus 11 plus 12 plus 20 plus 25 plus 30, that is 108 divided by 6, which is 18. So what was our assumption? 4. We got 3. My next assumption was 12, but I got 18. Now in next step I will assume this m1 value as a first cluster value and m2 value as a second cluster value. So my m1, now I'm going to update the value of centroid. So m1 value is 3 and m2 value is 18. Now see which objects come in m1 cluster. Okay, see, 2 is nearer to 3, so 2, 3, 4, 10 minus 3 is 7 and 10 minus 18 is 8, so 10 comes in m1 cluster. Check for m2. 11 minus 18 is 7 and 11 minus 3 is 8, so from 11 all points come under m2 cluster. So 11, 12, 20, 25, 30, all this comes in m2 cluster. Now find the average of this m1 cluster. Average of first m1 cluster is 4.75. Average of this m2 is 19.6. Now third step, again update this centroid and calculate and find the cluster. So my next centroids are 5 and 25. Suppose I am assuming my next centroid as a 5 and here is 20. Okay, now see which objects come in m1 cluster. 2, 3, 4. 10 minus 5 is 5 and 20 minus 5 is 15, so 10 comes in m1 cluster. 11 minus 5 is 6, 11 minus 5 is 6 and 20 minus 11 is 9, so 11 comes in m1 cluster. 12 minus 5 is 7 and 12 minus 20 is 8, so 12 also comes in m1 cluster. Again 20, so this is end of m1 cluster. Now see 20, 25 and 30, all this comes in m2 cluster. Now again find a centroid, average of this. m1 is equals to 7, m2 is equals to 25. Now assume this centroid as a cluster centroid. Okay, now see the fourth one. m1 as a 7, m2 as a 25. So first point is what? 2. So first point is 2, which comes in m1 cluster. 2, second is 3, fourth is 4, third is 4, then 10. After that 11 minus 7 is 4, 11 minus 25 is 14, so this comes in m1 cluster because here is minimum distance. Then 12 minus 7 is 5, 12 minus 25 is 13, so 12, then 20 minus 7 is 13 and 20 minus 25 is 5, so from 20 your next cluster is what? 25 and 30. So 20, your next cluster is 20, 25 and 30. Now find the average. m1 is equals to 7 and m2 is equals to 25. m2 is equals to 25. Now see here, previously you got m1 value as a 7, this one, m2 value as a 25. Again in fourth step you got the same value. That means you are find the clusters object. So your new clusters value K1 is equals to this M1 value 2, 3, 4, 10, 11, 12, and K2 cluster which contain 20, 25 and 30 numbers. So K1 is equals to first cluster which contains value 2, 3, 4, 10, 11, 12, and K2 cluster which contains value as 20, 25 and 30. Okay, these two are the clusters object.